Hello everybody, and welcome to Section 2, Part 2. The first thing we're going to be talking about is stratigraphy. What is this? So we've talked about how sedimentary rocks are deposited into layers. Stratigraphy is the science and the process of taking those layers and making sense out of them. How did this layer get to be here? What made it? And what does the order of the layers tell us about the story of what happened here? And all the principles that we're going to use for this were developed by your favorites, Nicholas Steno, James Hutton, and of course, Will Smith. We're going to talk about 6 principles, relatively small number, but as you'll see by the end of the lecture, using 6 very straightforward principles of stratigraphy, you can do a lot of work when it comes to figuring out a sequence of events or a story for an area. And the first, which we've talked about a little bit, is the principle of superposition. We have the very oldest layers at the bottom and the younger layers on top. Next, we would talk about cross-cutting. So over here on the left, what is the sequence? Well, first, we would say that this rock here and here was formed some way, and then after it was laid down, this cut through it. And this is true not only for different rocks, like this rock here that we see cutting through it, but also for features, like this right here, our fault. Cutting across these units, even though it isn't a rock unit, we would say that this must be older than these rocks here and here. It had to come after the thing which is getting cut. We talk also about lateral continuity. So looking here at the Grand Canyon, we have these rocks on this side, and then something which looks very similar to it, the rocks over here on the other side. Based on this principle, we could say that this and this over here, these were originally connected. These were originally a continuous horizontal layer which was laid down all over the entire area here, but has now been eroded away. And the same is true for these. This was once an entire continuous horizontal layer of rock. The same is true for these over here. This was once a continuous horizontal layer, laterally continuous, horizontally connected. We talk also about the principle of original horizontality. So rocks are deposited horizontally, sedimentary rocks, that is. Originally, these are all horizontal, so if we were to go out into the field, into a national park, hiking somewhere, and we see sedimentary rocks which are not horizontal, this tells us that something had to happen to cause this. Otherwise, they would have just been horizontal even till now. We also have the principle of inclusions. So we have this here, we might call this the host rock or the country rock. Then we have this, which is included inside of it, this little chunk. Well, there's 2 possible ways this could have happened, right? Either this was here first, and somehow this was inserted into the middle of it in a nice little neat hole, or, much more likely, much more possible, is the inclusion is older. And whatever this was ripped up into little pieces. And then whenever this rock came along, it surrounded those pieces and gobbled them up. The inclusions are older than whatever contains the inclusions. We also talk about the principle of faunal succession. Animals evolve over time. We look at our fossils here. What we know is that there is a sequence to the fossil groups over time. There's an order to these. So first this, and then these, and then these, moving upward in a sequence of fossils. That is, the fossils aren't randomly distributed through the rocks. It would be unusual if we found these up here, and it would tell us more than likely that something moved this, not that these necessarily would have went extinct and then come back somewhere up here. We're also going to talk about unconformities. So these aren't always the rocks themselves, but more to do with the gaps between them, or these areas where we have missing time. The best example is going to be something like this, disconformity. So we have our rocks up here, we have our rocks down here, and these are clearly different. This, in the middle of them, is a gap. It tells us that there is missing time here. And this is important. It tells us that this is not a continuous sequence up here. These are very, very hard to recognize sometimes in cases like this. There would be situations where somebody would say, maybe this is continuous. Doesn't necessarily mean there's missing time here. Maybe this was happening and then it changed over to this all at once. Well, that's not very likely, but the point is that these can be very, very hard to recognize because it's not really a discordant thing. It doesn't jut out. It's not sharp. There's nothing cutting across. You would have to take some time to be able to recognize it. So generally, what the gap is going to represent is some missing time where there was non-deposition. There was no deposition of new rock. Something was exposed at the surface and then eroded down. We can also talk about non-conformities. So here we have sedimentary rocks, the Grand Canyon, and beneath them are something that is most certainly not sedimentary rocks. You can see up here that there is this layered structure to them, these nice horizontal layers moving downward, horizontal layers, and then we have this, which to my eye at least has no layers in it whatsoever. So right here at the contact between these where we have sedimentary on top and not sedimentary on the bottom, it's called a non-conformity here. We also have angular unconformities. We looked at this in our last lecture. So what might have happened here is we have these layers deposited, and then something came along and folded them up. Then they were exposed at the surface here and worn down and eroded. And then this was put on top of them, flat. So we call this an angular unconformity because this is horizontal, but these are almost vertical, and between them you have this incredibly sharp angle. There's no way that this could have been continuous here moving up. And it might be helpful to break this down into steps. So we have the evolution of an angular unconformity, first with these four layers, A, B, C, and D, working our way up. These are deformed somehow. We don't have to worry exactly how this happens, but they get squished and folded up so that they're no longer horizontal or flat. They're exposed at the surface and eroded. And then finally, something new is deposited on top of them that is flat. So then we would look, and if we're looking at it from the side, like this, if we were to take a slice out of the earth, like we're slicing a cake, pull it out and look at it from the side, this is what we would see. And this is a very famous example, again in the Grand Canyon, of an angular unconformity, a nonconformity, and a disconformity all within the same sequence. And building on what we had said before, if somebody didn't know that there was a whole lot of time missing here, it could be difficult to tell that this is a disconformity. You might be tempted to think that this is continuous because these are horizontal, and these are horizontal right here. What is unmistakable, though, is this angular unconformity down here, where we have tilted rocks with flat rocks on top of them. Unmistakable is this giant nonconformity down here, where we have sedimentary rocks on top of non-sedimentary rocks, schist and granite. So what we were looking at, and what you might have heard of before, is the great unconformity. So here at the base of the canyon, where we start to get to crystalline rocks, is where this great unconformity rests. The next two numbers in the axis code are 4, 5. And this is something which is not just present in the Grand Canyon, but is present all over the world. There's sometimes a tremendous amount of time missing here. If you were going to tell the story of what happened in the canyon based on these rocks, you would need to account for the fact that there could be anywhere from 100 million to a billion years worth missing here. So the history, this was named in 1869 from John Wesley Powell during his documented trip through the Grand Canyon. So using all of our rules and everything that we have come up with so far, we could start to solve problems which are not super duper basic, even though we're using basic rules. Again, you imagine that we took a slice of the earth, like we're slicing a cake, and then we pulled it out and looked at it from the side. You see this? Using our rules, we could start to figure out the story of what had happened here.